Good morning, students. Now we are going to continue with the problems which are based on continuity of a function. Now in the last video, in the last problem, there was some problem. So that I will solve that first. Right? So the function, I will repeat one example once again. Let me consider the function defined by f of x is equals to mod x by x if x is not equal to 0 and it is given by 1 if x is equals to 0. We need to discuss the continuity of this function at the point x is equals to 0. At the point x is equals to 0. So, according to the definitions, what we have seen, let me consider the function at the point x is equals to 0. Here the function is defined by 1. So f of 0 will be equal to 1 here. F of 0 is equals to 1. Then the next one is we are going to consider the limits of this function. As you all know, the limit of the function, if it is the case of an modulus function, we are going to consider the LHL as well as the RHL. So limit of f of x as x tends to 0 minus. So that will be equal to limit of mod of x by x as x tends to 0 minus, which is equals to limit of minus x by x as x tends to 0 minus. So here x and x will get cancelled. So it is limit of minus 1 as x tends to 0 minus. So that is minus 1. So here the value of LHL is minus 1. Now the next one is RHL. So RHL is equals to limit of mod x by x as x tends to 0 plus, which is equals to limit of x by x as x tends to 0 plus, which is equals to limit of 1 as x tends to 0 plus, which is equals to 1. Now here one thing that we need to see here is whether LHL is equal to RHL. No. So here we say that since LHL is not equal to RHL, the limit does not exist. The limit does not exist, and hence the function is not continuous. It is not continuous at x is equals to 0. So this is the way how we discuss about the continuity of the functions. Now remember, the next example that I am going to consider, we are going to take one more example here. We will take one more example. Now the examples of the type. Now these were the modulus functions. Now let me consider one more example. The function is given by, it is defined in different manner, though it is the polynomial function, though it happens to be the polynomial function. Now how is the function defined? Let me tell you about that. The function is defined by f of x is equals to right, it is defined by 2x in the range if x is less than 0, and it is 0 if 0 less than or equal to x less than or equal to 1, and it is 4x if x is greater than 1. Now here we are going to discuss the continuity of the function at x is equals to 0. Now remember, just draw a real line. What are the points? 0, 1. So this is 0, this is 1. So for the values less than 0, the function is defined by 2x. Exactly x is equals to 0, it is defined by 0, and in this range, so it is defined by 0. So here also f of x is equals to 0, and for x greater than 1, it is defined by 4x. It is defined by 4x there. So this is the definition that we see. So in between 0 and 1, the points 0 and 1 are also included. It is defined by 0. For the values less than 0, the function is defined by 2x, and for the values greater than 1, the function is defined by 4x. They have told you to discuss the continuity of the function at x is equals to 0. They have told you to discuss the continuity of the function at x is equals to 0. Now here, at first one, at x is equals to 0, how is the function defined? At x is equals to 0, the function is defined by 0. So f of 0 is equals to 0. Next, second, since the function for the values less than 0 and for the values greater than 0, they are defined in different manners. They are defined in different manners. I have to check, I have to find the limits by using LHL and RHL method only. I have to use LHL and RHL method only. So LHL is limit of f of x as x tends to 0 minus, which is equals to limit of, how is the function defined for the values less than 0? It is defined by 2x. So it is 2x as x tends to 0 minus, which is equals to limit of 2 into 0 minus h as h tends to 0. So it is limit of, now substitute h is equals to 0, 2 into 0 is 0. So as h tends to 0, I will be removing this. So it is 0. So the value will be 0. Once I substitute h is equals to 0, 0 minus 0 is 0, 0, 2 into 0 is 0. Now RHL, I will be considering RHL. RHL is equals to, RHL will be equal to limit of, now for RHL I am going to consider the limit. So for RHL it is limit of f of x as x tends to 0 plus. So if it is values which are greater than 0, the function is defined by 0. So it is limit of 0 as x tends to 0 plus. So it is 0. Now we see that f of 0 is equals to LHL is equal to RHL. So here what we conclude is, since LHL is equals to RHL is equals to the value of the function at x is equals to 0. So it is 0. So hence what we say is the function is continuous. So here what we conclude, that the function is continuous at x is equals to 0. The function happens to be a continuous function at x is equals to 0. Now the next example that we are going to see is different one. So I shall take the next example. Now in the next examples that I am going to consider is this. Find the value of k. Next one is find the value of k if the function defined by the value of k, if the function defined by f of x is equals to k into x square minus 2x, if x is less than or equal to 0 and it is equals to 4x plus 1 if x is greater than 0, is continuous at x is equals to 0. Now here in this type of problems, here you are going to find one unknown. Here you are going to find one unknown here, and in such a manner that here it is been given that this function whatever is defined, here it is been given that this function whatever is defined is already continuous. So at x is equals to 0, how is the function defined? F of x is equals to k into x square minus 2x. So f of 0 is equals to 0, it will be 0 here. Then since for x less than 0 and for x greater than 0, the functions are defined in a different manner, and it is also stated that this function happens to be a continuous function. This function happens to be a continuous function. Here LHL should be equal to RHL, because initially we have already considered that this function happens to be a continuous function. Now since LHL is equal to RHL, limit of f of x has x tends to 0 minus should be equal to limit of f of x has x tends to 0 plus. Limit of f of x has x tends to 0 minus should be equal to limit of f of x as x tends to 0 plus. Now how is the function defined for the values less than 0? It is defined by limit of k into x square minus 2x as x tends to 0 minus will be equal to limit of 4x plus 1 as x tends to 0 plus. So k is taken out, so it is limit of x square minus 2x as x tends to 0 minus will be equal to limit of 4x plus 1 as x tends to 0 plus. Now here the substitution is 0 minus h. Here the substitution is 0 minus h. So here what I am going to do here is, here what I will be doing is, this will be 0 is equals to 0 is equals to, because here 0 minus h the bracket square minus 2 into 0 minus h, is it not? So it will be 0 minus h, 0. So it is minus 2 into 0 minus 0. So it is 0. So k into 0 is equals to 4 into 0 minus h, 0. So it is 1. So it is 0 is equals to 1, which is a contradiction to the fact. Here what we are getting? We are getting 0 is equals to 1, which happens to be a contradiction. Here you can have a look. Here if I substitute 0